Hi everyone. We have a pretty satisfying picture of the universe right now, I think. We've got three fundamental particles, the electron, proton, and neutron. We have a basic understanding of how they interact with one another. We can explain the periodic chart through quantum mechanics and the way the electrons surround the nucleus. We have a rough understanding of a second strong nuclear force. There's also a weak nuclear force, which I neglected to mention earlier. That weak nuclear force is what is in play in the decay of the neutron. And so we have, a very clean picture. The problem is nature's not so clean. There's actually a fourth fundamental particle called the neutrino that participates in all of these radioactive interactions. The neutrino is a very small, light particle, even lighter than the electron. In fact, initially people assumed that the neutrino had no mass at all. That's now known not to be true. It has a very slight mass, but it's very small. It has no charge. It doesn't participate in the strong nuclear force at all. It only participates in this weak nuclear force. It only really has to do with the decay of the neutron. And the reason people speculated that this must be occurring is that people were investigating the conservation of momentum, energy in these nuclear reactions, and things didn't quite balance. So there's quite a debate in the 1930s about, really what's going on. Are we seeing a violation of our fundamental conservation principles? Or is there a new particle that exists that, before now, there's really no evidence for at all? And so there's kind of a debate, eventually that got resolved. That now this fourth subatomic particle is now known to exist. But in the midst of those investigations, slamming, these atoms together, the idea of atom smashers started to get produced. The reality is that the subatomic, subnuclear world is extremely more complicated than what we would imagine. This picture here represents a typical event that occurs in these atom smashers, that once you get, say 2 protons or even 2 electrons to slam into one another with enough energy, if that energy is above and beyond, the E equals mc squared threshold for the mass of some of these extra particles, that energy can actually get absorbed and create a new particle. And so you can actually get the creation of particles in these atom smashers. And these much heavier subnuclear particles were discovered in these atom smashing events. And so as people started to collect this data and these evidence, all of a sudden this explosion of elementary particles occurred. All of a sudden we went from having 4 basic fundamental particles to all of a sudden hundreds. And so this phase in the history of physics is called the particle zoo. All of a sudden, within the span of 10, 20 years, there's just this explosion of elementary particles, which then begs the question, well, are these really elementary at all? I mean, essentially what we've got is a second level of a periodic chart kind of begging itself, saying there must be some substructure to all of this confusion. And that is precisely what happened when people started to investigate the idea of quarks.